We're going to find the p-value for a hypothesis test from the t-test statistic. We'll do this using this table. Let's read it. Fred was testing the null hypothesis that the mean equals 0 versus the alternative hypothesis that the mean is different from 0. His sample had 8 observations, and his test statistic was t equals 2.98. We're going to assume the conditions for inference are met, so we can answer the question, what's the approximate p-value for Fred's hypothesis test? It's worth noting that this is the formula for a t-test statistic. Of course, we are given the statistic in this example. If we had to calculate it, we would need to do x bar, the sample mean, minus the assumed population mean, in our case that's 0 from the null hypothesis, divided by the sample standard deviation over the square root of the sample size. The reason we would use a t-test here is because this is a hypothesis test with means, as opposed to a hypothesis test with sample proportions where we would use a z-test. Again, we don't have to calculate the test statistic because it's given to us as 2.98. Now, to understand how we can use this and our table to calculate the appropriate p-value, it might be helpful to sketch a picture. So here's a quick sketch of a t-distribution with mean mu. In our case, again, we're assuming that's 0. Now, note that the alternative hypothesis is not that the mean is greater than 0. It's also not that the mean is less than 0. The alternative hypothesis is that the mean is different from 0. So this is what's sometimes called a two-tailed test. We're interested in the area of the t-distribution that is more than 2.98 above the mean, and the area that is more than 2.98 below the mean. In total, these two tails add to the probability that we would get a sample with a t-score of at least 2.98, assuming the null hypothesis is true. And so if this p-value is small enough, we may reject the null. This table gives single tail probabilities, so whatever number we find, we're just going to have to double it so we get both tails accounted for. Let's look in the row with the appropriate degrees of freedom. The degrees of freedom is just the sample size minus 1. In our case, that's 8 minus 1, which is 7. So we're looking in this row for the number closest to our test statistic of 2.98. We see that here, 2.998. Our test statistic is a little bit less than this, so the exact single tail probability would be between 0.02 and 0.01. But our statistic is really close to 2.998, so we'd be pretty confident saying the single tail probability is about 0.01. So the area of this single tail is about 0.01. And the t-distribution is symmetric, so of course the area of this lower tail is also about 0.01. Again, this is a two-tail test. That's why we have to double the 0.01 to get our final p-value of about 0.02. We could also go a step further and make a conclusion for Fred's hypothesis test. 0.02 is less than most critical values. It's certainly less than 5%, which is a pretty typical critical value. So since it's so small, we may reject the null hypothesis. We have pretty convincing evidence that the true population mean is different from 0. Now, of course, if you had a stricter critical value, you may not reject the null. But regardless, the p-value is about 0.02, and that's how you find it from the table. Thanks for watching, and let me know in the comments if you have any questions.